Section 3.7, Arguments and Truth Tables. We have two objectives. The first one is to use the truth tables to determine validity and to recognize and use forms of valid and invalid arguments. An argument consists of two parts. The first part is called premises. The second part is called conclusion. The premises are the given statements. The conclusion will be the result determined by the truth of the premises. The valid argument with the conclusion of the argument is true whenever the premises are assumed to be true. The invalid argument, also called a fallacy, so this case, the case that at least one of the truth value is not true. The truth table can be used to test validity. Recall the tautology is the case that all combinations return the result as a true statement. Testing the validity of an argument with a truth table. Step number 1, define each simple statement. Step number 2, express the premises and the conclusion symbolically. Use the notation for the simple statements such as P, Q, R, and so forth. Number 3, write a symbolic conditional statements of the form premises number 1, number 2, number 3, and connect them with the and or the conjunction and all premises together, then conclusion. So at this step, we form the symbolic form or as a compound statement in the symbolic form. Number 4, construct a truth table. Number 5, if it is a tautology, then the argument is valid. If it is not a tautology, that means at least one of the combination return the false result. The argument is called invalid. Let's get started. For this example, use the truth table to determine whether the following argument is valid or invalid. Valid means tautology. Or all gonna return true statement. From this compound statement or the symbolic form provided, as you see the first row, this one is called premise number 1. And the next gonna be premise number 2. When you draw the line with the 3 dots, so this one is called conclusion. To form the symbolic form, starting with the quantity for premise number 1, which is P then Q. Another quantity for premise number 2, which is P and Q. Connect these two premises with the connective and, put the bracket around, have the arrowhead to form the conditional statement to the conclusion, which is the Q. Now we have the symbolic form of the compound statement for this problem. After that, we're gonna construct a truth table. When you construct a truth table, see how many simple statement that you have. You have P, Q, so that means you have 4 combinations. You're gonna form the table for P, the column for P, for Q, the column for the first premise, which is P then Q, the column for the second premise, which is P and Q, the column for the left side of the arrow, which is in the bracket or the antecedent, and after that we build another column for the entire symbolic form. And we're gonna build 1, 2, 3, 4, 5, 6 columns. Okay, to make 6 columns, I'm gonna start with building or create a table. It's gonna be 6 columns and 4 rows. Oh, where did it go? Oh, where did it go? Do it again. Insert table. 6 by 5, and then bring it down here. Expand it a little bit more. Okay, the first 2 columns is known by default because for the column P and Q. So statement P, statement Q, the full combination true, true, false, false. For the Q, gonna be true, false, true, false. The next column for the P then Q, P then Q or premise number 1. The next column gonna be P and Q or premise number 2. The next column is gonna be the compound statement in the bracket, which is P then Q and P and Q. And the last one gonna be the compound statement that we're gonna make it as a conclusion. All right, so getting started with, let me expand this a little bit. All right, so for the column P then Q, recall the P then Q or the if then or the conditional statement only antecedent true, the consequent false. It will return false statement, otherwise it's gonna be true. The first combination, true then true, the answer gonna be true. True then false, this is the one that return false result. False then true, gonna be true. False and false, gonna be true. The next one is P and Q. For the and, only when both of them true, the result gonna be true. Otherwise, you're gonna get a false result. For the column P and Q, P and Q, T and T, true and true gonna be true. True and false will be false. False and true gonna be false. False and false gonna be false. The next column is the compound statement. When you connect these 2 columns with the and, or connect the 2 premises with the and, so T and T or true and true gonna be true. False and false gonna be false, and then false, and then false. And the last one, whatever that you just got, you're gonna do the conditional statement, which is this one. Conditional statement with the Q. Again, for our convenience, I'm gonna create like kind of a small column here. Is a column Q. And we're gonna do if then to get the final result, which is the result for this compound statement in here. Okay, the Q column, we just copy from the second column, which is the true, false, true, false. With the if then, true, then false, that will return the false result. This is true, then true, gonna be true. False, then false, gonna be true. false and true gonna be true, false and false gonna be true. It returns all true value. That means it is a tautology. When it is a tautology, we can say this is a valid argument. So we can say the argument is valid.